Introduction to computing and programming can feel bigger and more mysterious than it really is, especially when people only hear slogans about it and never see the actual materials behind the work. In this walkthrough, we are going to teach from the inside out by opening the real course and project references, because this topic shows that computing is learnable, hands-on, and directly connected to real projects and career movement. The gap is usually not ability. It is access to structure, direction, and visible proof of work. This is not only educational. It connects to work, visibility, value creation, and a larger market path. By the end, the viewer should understand not only what this is, but how it can become a real direction worth acting on. Introduction to computing and programming. Start with what a computer actually is: input, processing, memory, storage, and instructions. Start by slowing the idea down enough that a beginner can see what is happening, why it matters, and where it appears in the real learning path. In plain terms, a computer is a machine that receives input, processes instructions, stores data, and produces output. A good way to teach this is to open Introduction to Computing and Programming Erudite WBT, get hands-on Introduction to Computing and Programming, so the learner can see the idea inside real materials instead of hearing it as a vague claim. Inside those materials, the sequence to notice is: learn how computing actually works before you learn how to chase syntax, what this course solves, the missing computer model. In practical terms, the learner should notice CPU, RAM, storage, motherboard. What we want to land before moving on is that most beginners fail because they are missing the computer model and the tooling model. A strong teacher does not stop at explanation, so the next visible action should be to open the start page. Show the real beginner setup path: device-operating system-terminal-editor-git-first files. This is usually the point where learners feel the material getting abstract, so the explanation has to translate the idea into visible parts and a believable workflow. In plain terms, an operating system is the layer that manages hardware resources, files, processes, and the applications running on a device. To keep the explanation concrete, bring up Introduction to Computing and Programming Erudite WBT, start Introduction to Computing and Programming, so the learner can see the idea inside real materials instead of hearing it as a vague claim. Those pages already give us a teaching order: learn how computing actually works before you learn how to chase syntax, what this course solves, the missing computer model. The idea worth carrying forward from this scene is that the first stack is not just code, it is computer-os-terminal-editor-git-project. Explain why HTML, Markdown, CSS, shell commands, and simple scripting are the safest early playground. A useful teaching move here is to connect the concept to pages, files, tools, and examples the viewer can actually open instead of leaving it at the slogan level. In plain terms, HTML defines the structure and meaning of the content on a web page. If we want the viewer to trust the explanation, we should actually show Programming Languages Introduction to Computing and Programming, get hands-on Introduction to Computing and Programming, so the learner can see the idea inside real materials instead of hearing it as a vague claim. The explanation becomes easier when we follow the structure already visible on the page. Different languages do different jobs. You do not need all of them at once, what each one is for: HTML. If the viewer remembers only one thing from this section, it should be that HTML, Markdown, CSS, and shell commands are legitimate beginner wins, not side topics. The scene should end with momentum, which means the learner can now run the Git Basics lab. Show the difference between learning syntax and learning the working environment. The point is not to collect terminology. The point is to understand how the concept behaves inside an actual piece of work. In plain terms, a working environment is the full setup where code actually lives and runs: files, tools, paths, shells, editors, and version control. The cleanest way to anchor this section is to walk through Introduction to Computing and Programming Erudite WBT, Terminal Hands-on Introduction to Computing and Programming, so the learner can see the idea inside real materials instead of hearing it as a vague claim. The most useful guide rails in the source material are: learn how computing actually works before you learn how to chase syntax, what this course solves, the missing computer model. The lesson to lock in here is that proof matters more than perfection. A small repo and a clean commit already count. Quick reset, lock in the key takeaway before we move to the next layer. Route viewers into the Intro to Computing and Programming repo and GitHub Pages course. Start by slowing the idea down enough that a beginner can see what is happening, why it matters, and where it appears in the real learning path. In plain terms, computing is the practice of representing information, processing it through instructions, and turning that processing into useful